looking at the moon. Now, if you're looking at your reference table, go get your reference table out. And I need you looking at page 15. Where it says solar system data. So if you look at the moon, which is all the way at the bottom, and you look for the column of period of revolution, it says 27.3 days. And the column of period of rotation at the equator, it says 27.3 days. So the whole idea, since its period of rotation is the same as its period of revolution, we always see the same side of the moon here on the Earth. So in other words, we never see the dark side of the moon, is what we'll tell you. Earlier, I had made a note that it's, when I was looking at a calendar, 29.5 days was my lunar cycle. That's because this does not take into account that the Earth is also revolving around the sun. So that extra 2.2 days is because the Earth is also moving. If I have you go outside and look at a full moon, you'll see part of it is illuminated and the other part is dark, even though it's a full moon. That's because the composition is different. The highlands of the moon are that light color of the moon, that white. That's because just like the rocks that we find in the Adirondacks, they're northricitic rocks. The Marias, or maras of the moon, are the dark part, and they're made of basalts. Remember, basalt you actually had to identify for me earlier this year. All right, craters of the moon, that's that bowl-shaped depression caused by collision being asteroids or being meteoroids. We need to talk about what are the three theories on how the moon was created. First theory is the collision theory. The whole idea is another planet actually collided with the Earth, just at the right angle, not a direct hit, but just at the right angle that it hit, and then it came back. With that collision, it caused all this debris to go out into space, far enough away from the Earth so that it didn't gather back in, but it was actually able to form a moon. The capture theory means that something the size of the moon was actually captured by the Earth's gravity, which this one doesn't make sense physics-wise. And the third one is molten Earth was spinning so fast that that chunk of molten Earth actually spun out, and then it became the moon as it also cools. Whole idea is that if that was true, then the composition of the Earth should be identical to that of the moon, and it's not. So the best one that the scientists think is the collision theory. Hence you got the little asterisk next to it. There's enough similarities between the Earth and the moon, but they're not identical. And that would be because with the collision of what they call Orpheus, the other planets, you're getting, for the moon, getting some of that material plus the spin-off of the Earth material. So you have some similarities, but not identical chemical similarities. All right, apogee and perigee, we already talked about in your vocab. Apogee, A, away, it's when the moon is furthest away from the Earth, so it's going to look smaller. Perigee is when the moon is closest, so therefore it's going to look larger. And the moon, if you go out every night and you look for the moon appears to rise and set 50 minutes later each night due to the moon's revolution around the Earth. All right, phases of the moon. They are caused by the moon revolving around the Earth. Earth is going to cast a shadow on the moon. The moon and the Earth, if I'm looking for alignment, they're usually off vertically about 5 degrees. So they're not usually perfectly aligned. So going over this diagram. Here's the Earth, here's our moon, and if you look, I have 8 different moons on the diagram. The sun is over on the left-hand side. So if you look at the moon, original moon that I drew, the side facing the sun, or the left side of the moon, is illuminated. The side away from the sun is going to be dark. Now, as the moon revolves around the Earth, its frame of reference is different for us. So what I did was I drew blue lines to show what we would see on the Earth. So if we were on the Earth, staring at the moon, we would see it totally dark. Also known as the new moon for us. Now the new moon will hit its peak around noon on the clock. If I am revolving counterclockwise as the moon revolves around the Earth, our next phase, same thing, blue line. Oops. If I'm looking from the Earth, I'm going to see just a sliver of it illuminated. And if I have you looking, you're coming here. This is going to be your right side. So a sliver on the right side is illuminated and the rest of it's dark. So if that's why I have this crescent shape. That's our waxing crescent. Waxing means it's getting more and more illuminated or lit, and waning is going to be less and less illuminated. Now, with my waxing crescent, that is going to hit its high point at 3 p.m. Next one, I'm on the Earth, I'm looking at the moon. There's my left, here's my right. The right side, half of it is illuminated. The right half is illuminated. That's our first quarter. That's going to peak at 6 p.m. Go to my next one. Frame of reference, what I'm seeing is most of it's illuminated, just a sliver on the right, sliver on the left is not illuminated. So that one is my waxing gibbous. We're close to being a full moon, just missing a sliver. That's going to peak around 9 p.m. I'm on the Earth, I'm looking at the moon. To me, I'm seeing the side that's totally illuminated. It's my full moon. That's peaking at midnight. Next one, I'm on the Earth, looking at the moon. So the majority of the left is illuminated, just a sliver on the right is not. So I'm back to a gibbous because I'm close to being a full, but I'm missing that sliver. So I'm a gibbous. I'm losing illumination. It's waning. I'm on the Earth, looking at the moon. The left side is illuminated. Last quarter. It's peaking at 6 a.m. Last stage. I'm on the Earth, looking at the moon. Majority of it's dark, just a sliver on the left is illuminated. That's my waning crescent. And that's going to peak at 9 a.m. Now, if I put you outside during the night, or during the day, because you can see the moon during the day also, if the left side is illuminated, it's waning. If the right side is illuminated, it's waxing. Easiest way to remember this is alphabetical. What comes first, left or right? Left. What comes first, waning or waxing? Waning. So waning on the left, waxing on the right. Next, eclipses. Remember I told you, the moon and the Earth aren't always aligned. They're about 5 degrees off vertically. Well, in order to get an eclipse, they got to be perfectly aligned. So it doesn't happen every full moon or new moon. This one, we need to look about your shadow. If you go outside and stand in the sun, you'll see your shadow has two parts to it. There's that darker part of the shadow, known as your umbra, and then there's that gray fuzzy area surrounding your shadow, and that's your penumbra. First, we're going to start talking about a lunar eclipse. Lunar eclipse, a couple things. It's got to be a full moon. With that one, the moon and the earth have to be perfectly aligned. Like I said, doesn't happen every month. The dark area, so the earth is casting a shadow on the moon. That dark area is your umbra. That light gray area is your penumbra. So this and this are your penumbra, this area is your umbra. If you have a total lunar eclipse, your moon and your earth are perfectly aligned. Next lunar eclipse, July 4th of this year. Solar eclipse. This one, I need a new moon. Notice the moon is in between the sun and the earth. Same thing, the moon and the earth have to be in the same plane. They can't be off that 5 degrees like it normally is. The moon is smaller than the earth, so its umbra is not going to cover the whole part of the earth. So not everyone is going to actually see the solar eclipse. Then you have your gray area or your penumbra. So your the penumbral eclipse. All right, the next total solar eclipse for us here in New York State, it's going to take this path to see in the yellow, is April 8th, 2024. So you guys will be graduated, but think of me, April 8th, 2024. It'll be all over the news like it was a few years ago when everyone went and got their special glasses. Remember, don't look at the sun. So look at the yellow. That's where you're going to have a total eclipse. We need to talk tides. Tides are going to tie into the gravitational attraction between the sun, earth, and the moon. So if I'm looking at the sun, if the sun and the moon are in the same plane, it's pulling the water that's on the earth with greater force. So the areas towards the moon or the sun, the water on the opposite side is going to get pulled closer or more towards the moon or the sun. So this area is the water is going to bulge, or we say it has a high tide. It's taking water away from the sides that are coming in and out of the screen. So since water is being pulled from that area, that's going to be your low tide. Remember, the earth is rotating, so approximately every 6 hours you go from a high tide to a low tide, and then another 6 hours back to a high tide. So the spring tide is your highest high tides, your lowest low tides. That has to be a full moon or a new moon, because the moon and the sun have to be working together. Neap tide. The moon and the sun aren't working at all together. The sun is pulling one direction, and the moon is pulling the other direction. Remember, your quarters should be this way. Moon is pulling this way, sun is pulling this way. So with that one, only because the moon is closer to the earth, the the moon wins slightly. With that one, your low tide's not really low. There's not a huge change between normal. And the high tide's not really high. It's not a lot of change between what it normally is. All right, remember, so the moon only wins because it's closer. This, neap tides, first and last quarter. Moon pulling one direction, sun pulling opposite direction.